Look up at the night sky. On a clear night, away from city lights, the universe unfolds above us in a breathtaking display. Each twinkling light is a sun, perhaps with planets of its own, orbiting in silent grandeur. These distant suns, like our own, may harbor worlds we can only dream of. For millennia, humanity has gazed at the cosmos with wonder, tracing patterns in the stars, weaving myths, and pondering our place in the grand scheme of existence. The night sky has always been a source of inspiration and mystery. We are explorers at heart. It's woven into our DNA, this innate drive to venture into the unknown, to push beyond the horizon, to discover what lies beyond. Mars, that rusty red point of light, a beacon in the night, has captured our imagination like no other world. It beckons us with the promise of discovery, the potential for new beginnings, and the allure of the unexplored. Why Mars? What is it about this particular planet that draws us in so powerfully? Why pour so much effort, resources, and ingenuity into reaching this distant planet? Why dedicate ourselves to overcoming the immense technological and logistical hurdles that stand in our way? The answer: survival. It's a fundamental imperative, a deep-seated instinct to protect ourselves and ensure the continuation of our species. Not just ours, but the survival of consciousness itself. The preservation of knowledge, culture, and the very essence of what makes us human. Life on Earth is precious yet vulnerable. Our planet, a vibrant oasis in the vastness of space, is not immune to the forces of nature and the potential for unforeseen disasters. A single catastrophic event, whether it be an asteroid impact, a global pandemic, or a self-inflicted environmental crisis, could erase millennia of progress, plunging humanity into darkness. Becoming a multiplanetary species is not just adventure, a thrilling quest for new frontiers. It's insurance for humanity, a safeguard against existential threats, a way to diversify our portfolio of existence and ensure that all our eggs aren't in one basket. Spreading among the stars safeguards our future. By establishing settlements on other worlds, we increase our chances of long-term survival and create a more resilient civilization. Consider the dinosaurs, a cautionary tale etched in the fossil record. Rulers for millions of years, masters of their domain, perfectly adapted to their environment, undone by a cosmic accident, a random event that reshaped the planet and wiped them from existence. They had no way to escape, no means to mitigate the disaster, no plan B. We are different. We possess the capacity to anticipate threats, to innovate, and to adapt. We have the intellect, the ability to understand the universe and our place within it, curiosity, the insatiable desire to explore, to learn, and to push the boundaries of knowledge and technology to reach for other worlds, to build spacecraft, to navigate the cosmos, and to establish a foothold beyond Earth. Mars is our first, most tangible step outward. It's the closest, most accessible planet that offers the potential for long-term habitation. The dream of Mars is more than planting a flag, claiming territory, or seeking resources. It's about expanding the domain of life, seeding new worlds with the potential for growth, evolution, and the flourishing of consciousness. It's about understanding our place in the cosmos, gaining a deeper appreciation for the interconnectedness of all things, and recognizing the fragility and preciousness of life, and pushing the boundaries of what's possible, inspiring future generations to dream bigger, to reach further, and to strive for a better future for all. The challenges are immense, the obstacles formidable, the risks significant, the journey arduous, demanding unwavering commitment, resilience, and a spirit of collaboration. Yet the spirit of exploration compels us forward, driving us to overcome these challenges and to persevere in the face of adversity. We look to Mars not just because it is there, a tantalizing target in our cosmic sights, but because it is a crucial part of our unfolding cosmic story, a pivotal chapter in the ongoing saga of life's expansion into the universe. Our destiny is waiting, beckoning us to embrace the unknown and to shape our future among the stars. And Mars is the next chapter, the next great adventure in the human story. The journey begins with a single question, a spark of curiosity, a moment of inspiration, a daring leap of imagination. What if we could go? What if we could break free from the confines of our home planet and venture into the vast unknown? And the answer, a resounding affirmation of our potential, our courage, and our unwavering spirit of exploration. We must try. We must dare to dream, to innovate, and to push the boundaries of what's possible. The future of humanity may depend on it. High above us, A celestial wanderer graces the night sky. Mars hangs there, a tantalizing presence, beckoning us with its mysteries. For millennia, it has captivated stargazers, poets, and scientists alike, sparking our imaginations and fueling our dreams of exploration. A beacon of rusty red, a fiery ember against the velvet backdrop of space. This distinctive hue, born from iron oxide on its surface, has earned it the moniker, the Red Planet, a name that resonates with both its visual allure and its potential for harboring secrets of the past. Our planetary neighbor, the fourth rock from the Sun, occupies a unique position in our solar system. It's close enough to study in detail, yet far enough to possess an environment distinctly different from our own, offering a natural laboratory for understanding planetary evolution. For centuries, astronomers have charted its surface, meticulously mapping its features, from the broad plains to the towering mountains. Each observation, each discovery, has added another piece to the puzzle of Mars, slowly revealing its complex geological history. Its polar caps, shimmering expanses of frozen water and carbon dioxide, expand and contract with the Martian seasons, a visual testament to the planet's dynamic climate. These icy reservoirs hold clues to the planet's past water abundance and potential for habitability. Its seasonal changes, marked by dust storms that engulf the entire planet and subtle shifts in atmospheric pressure, paint a picture of a world in constant flux, a world where the forces of nature are on full display. Early observers imagined canals and civilizations fueled by wishful thinking and the limitations of their telescopes. These fanciful notions, though ultimately proven false, ignited the public's imagination and cemented Mars's place in popular culture. But the real Mars is even more intriguing, a world sculpted by ancient volcanoes carved by colossal floods and shaped by the relentless forces of wind and radiation. It's a landscape that speaks of a dynamic past and hints at the possibility of a hidden present. Vast canyons like Valles Marineris, a scar across the face of the planet, dwarf even the Grand Canyon in size, a testament to the immense geological forces that have shaped Mars over billions of years. Volcanoes like Olympus Mons, the largest volcano and highest known mountain in our solar system, stand as silent sentinels, reminders of a time when Mars was a geologically active world. Mars is a world of extremes, a place where towering mountains meet deep canyons, where scorching deserts give way to icy plains, and where the very air is thin and unforgiving. Its thin carbon dioxide atmosphere offers little protection from the sun's radiation and contributes to the planet's dramatic temperature swings. And wild temperature swings make it harsh yet fascinating, a challenging environment that pushes the boundaries of what we know about habitability. Evidence suggests Mars was once warmer and wetter, a time when liquid water flowed freely across its surface, carving out riverbeds and filling vast lakes, with rivers and lakes dotting the landscape, creating an environment that may have been conducive to the emergence of life. The possibility of past or present life drives our curiosity, fueling our relentless quest to understand whether we are alone in the universe. If life arose on Mars, even in its simplest microbial form, it would revolutionize our understanding of biology and our place in the cosmos. It would mean life is common in the universe, suggesting that the building blocks of life are readily available, and that the conditions for its emergence may be more widespread than we previously thought. Robotic explorers like Perseverance, with its advanced scientific instruments, are tirelessly traversing the Martian surface, collecting data and searching for clues. They search for ancient biosignatures, the telltale signs of past life, preserved in the rocks and sediments of ancient Martian environments. Mars is not just a dusty rock, it's a treasure trove of scientific information, a time capsule preserving the history of our solar system. It holds secrets about planets, life, and our own origins, offering invaluable insights into the processes that have shaped our world and the potential for life beyond Earth. The more we learn, the more we uncover the planet's hidden complexities, and the more we appreciate its scientific value. The more compelling the reasons to go, to send human explorers to walk on its surface, to conduct in-depth research, and to unlock the remaining mysteries of the alluring neighbor in a crimson cloak. Reaching Mars is no simple jaunt. It's not a quick trip to the corner store. It represents one of humanity's greatest technological and logistical challenges. It's an epic voyage across millions of miles, a testament to our ambition to explore beyond our homeworld. The sheer scale of the distance is hard to fathom, requiring years of planning and preparation. At their closest, Earth and Mars are 34 million miles apart. This alignment, however, is a rare occurrence. At their furthest, over 250 million miles separate us from the red planet. This vast difference is due to the elliptical orbits of both planets around the Sun. The journey takes 6 to 9 months, even with our fastest rockets, pushing the limits of human endurance and spacecraft reliability. These extended mission durations demand careful consideration of resource management and crew well-being. Astronauts will face hazards, many of which are unique to the deep space environment. The vacuum of space, a near-perfect void, poses a constant threat to unprotected humans and requires specialized suits and equipment. Temperature extremes, ranging from hundreds of degrees Celsius in direct sunlight to hundreds below freezing in shadow, necessitate robust thermal protection systems. And micrometeoroids, tiny particles traveling at incredible speeds, can cause significant damage to spacecraft and spacesuits. Radiation is a major threat, one of the most significant challenges for long-duration space travel. Outside Earth's protective shield, cosmic rays can damage DNA, increasing the risk of cancer and other health problems for astronauts. Shielding spacecraft without making them too heavy is a huge engineering challenge requiring innovative materials and designs. Innovative solutions are needed to protect our explorers, pushing the boundaries of materials, science, and engineering. The psychological impact of long-duration spaceflight is just as real, and perhaps even more insidious than the physical dangers. Isolation, stress, the constant awareness of being millions of miles from home, all take a toll. And conflict, inevitable in a small, confined group, can be magnified by the pressures of the mission. Crew selection, support, and mission design are as crucial as the technology, ensuring the team can function effectively under extreme conditions. Bridging the Gulf to Mars is a test of human spirit and resilience, a demonstration of our ability to overcome seemingly insurmountable obstacles. Every challenge overcome brings us closer to the red planet, inching us forward on this grand endeavor. The journey will redefine what it means to be explorers, pushing the boundaries of human achievement and inspiring future generations. Mars awaits those bold enough to cross the void, a beacon of scientific discovery and a testament to the enduring human desire to explore the unknown. To conquer interplanetary distances, we need new ships capable of carrying crews and cargo to Mars and back. Enter SpaceX's Starship, a fully reusable launch system aiming to revolutionize space travel. Most rockets are single-use, but Starship's reusability could dramatically lower costs. This makes a permanent human presence on Mars economically feasible. Starship consists of the Super Heavy booster and the Starship spacecraft, together taller than the Statue of Liberty. Powered by Raptor engines and fueled by methane, potentially producible on Mars, Starship is designed for round trips. Other agencies like NASA with its SLS are also developing heavy-lift rockets. Competition and collaboration are accelerating innovation. These machines are our tools to carve a path to Mars and beyond. The next era of exploration is being built now. Before Mars, we practice closer to home, on the Moon. NASA's Artemis program aims to establish a long-term lunar presence, including a base and the Gateway Station. The Moon is our celestial laboratory, where we test technologies and human endurance for Mars. Extracting resources, building habitats, and recycling air and water are all vital skills. Living on the Moon teaches us to survive in hostile environments and prepares us for Mars. The lessons learned will directly inform our first human missions to the Red Planet. By conquering the Moon, we build the confidence to take the next giant leap. Landing on Mars is just the beginning. The real challenge is surviving and thriving. Mars's thin, carbon dioxide atmosphere offers little protection or air to breathe. Radiation is a constant threat. Habitats must be shielded, perhaps buried or covered with Martian soil. Temperatures average -63 Celsius, demanding robust heating and insulation. Water ice exists at the poles and underground, essential for drinking, growing food, and making fuel. Self-sufficiency is key, extracting water, generating oxygen, producing building materials, and growing food on Mars. Advanced in-situ resource utilization will reduce dependence on Earth. The goal, a sustainable, resilient Martian outpost. Every innovation brings us closer to a new home on a new world. Mars will test our ingenuity like never before. The first settlers will lay the foundation for future generations. Survival on Mars is the ultimate test of human adaptability. Humans on Mars is more than a technological feat. It's a statement about who we are. It speaks to our curiosity, our drive to explore, and our capacity for the impossible. Establishing a self-sustaining presence on another planet would transform us into a spacefaring civilization. There are ethical questions. Should we go? How do we protect Mars and ensure benefits for all? Yet, the pull of Mars remains strong. A new frontier, a chance to expand our horizons. The journey will be perilous, but the human spirit thrives on challenge. What role will you play in this cosmic adventure? The story of Mars is ours to write.